Hi guys, Audrey here. Let's find a consistency condition. So in this case, we're given an augmented matrix and we want to know what are values of H and K so that this matrix represents unique solution, infinite solutions, no solution. So first we know that we want to reduce this to row echelon form, just REF. We do not need to get this all the way to our REF. Our REF is when we actually want to write down solutions. Now we just want to count solutions. So we're going to do some row reduction. We're going to pick a pivot in our first column. That pivot will be 1. And then I will do row 2, oops, I want to do that in red, row 2 minus 2 row 1, and row 3 plus row 1. And this is going to give us 1, 0, 0. My row 1 is not changing, 1K, 2. So then I'm doing 3 minus 2 times 1. That's 1. 5 minus 2K. Well, there's nothing we can do about that there. And then 4 minus 2 times 2, that gives me a 0. Row 3 plus row 1, that's negative 1 plus 1, that's a 0. This is 3 plus K. And this is H plus 2. Well, this is in REF. And again, it's a good thing because that we don't need our REF. I don't know why I said again, because this right here, this 3 plus K cannot be a pivot, because what if K is negative 3? If K is negative 3, then that's 0, and we can't use 0 to make zeros. Okay, so that said, when we're looking at these problems, the first thing that we want to do is check if there's an obvious contradiction. In this case, that would be 0, 0, 0, and then not 0. So we're looking for that row of zeros there. There isn't one. So there is no obvious contradiction. Now, the next thing goes with what I just said. We said if K is equal to negative 3, then that's a 0, and we can't make zeros in the rest of the column with a 0. If K is not equal to negative 3, then that's a pivot, and I have a pivot in every column. And how many solutions does a pivot in every column represent? 1. So really, we know we have one solution everywhere, except for this possibility of not having a pivot right there. So we want to plug in that K equals negative 3 to see what happens. In other words, we're taking the 3 plus K and setting it equal to 0. That gives us K equals negative 3. And we're saying this is what would cause a column to not have a pivot. And we want to plug it in to see what happens when that column doesn't have a pivot. So here I'll have 1, 0, 0, 1, 1, 0. I'm plugging it into the REF form of my matrix here. And then I have negative 3, I'm replacing K. 5 minus 2 times negative 3, that's 5 plus 6, that's 11. And then we have the 0 there. And then I have 2, 0, H plus 2. Well, now check it out. We do have that 0, 0, 0 thing that could give us an obvious contradiction. So here we have an obvious contradiction when H is equal to negative 2. So if H is equal to negative 2 and K is negative 3, K equals negative 3 and H is equal to negative 2, I'm sorry, H is not equal to negative 2, that's where the contradiction comes from, then we have no solution. However, if H does equal to negative 2, then we have 0, 0, 0, 0. So we have that row of zeros. Does not cause a contradiction, but we still have a column without a pivot. And a column without a pivot, when we are consistent, means infinite solutions. So over here, I would have infinite solutions. So my final answer here is that the unique solution occurs when we have a pivot in every column. So that is when K does not equal to negative 3. And H, it turns out, does not matter. H can be anything in the world. H could even be negative 2, causing us to have 0 there because we have a pivot in that column. So H can be anything. Now B was my infinite solutions. So here, this happened when k was equal to -3 and h is equal to -2. So that's infinite solutions. And C happened when k was equal to -3 and h was not -2. That's my no solution. And that is my final answer. So really these problems, you're noticing they come down to counting pivots and figuring out what k values might cause us to not have pivots. And when we don't have pivots, do those things cause contradictions? Or if not, therefore we have infinite solutions. Anyway, hope this was helpful. Bye guys.